Welcome to The Explainer. Today, we're going to pull back the curtain on the invisible rules that literally make our entire digital world work.
I mean, have you ever really stopped to think about it? How does your phone in, say, New York, instantly pull up a website from a server halfway across the world in Tokyo? It feels like magic, but nope, it's actually a masterpiece of engineering. Well, the secret sauce is something called a protocol. You can think of it like a universal rulebook. Without this shared language, oh man, it would be total digital chaos. A device from one company couldn't understand a single thing from another. This is what makes it all possible.
So in this explainer, we're going to break this whole thing down by pretending the internet is one giant global postal service. We'll look at how messages get packaged, how they're delivered, and even the kinds of digital neighborhoods they travel through. All right, so let's dive right in. First things first, how does a message even get ready for its big journey? Before a single bit of data goes anywhere, it has to be encoded. And this is where protocols are just so smart. They know how the data is traveling. So if your computer is plugged in with a cable, the protocol zaps your data into electrical signals. But if you're on Wi-Fi, it turns that exact same data into radio waves. It's exactly like choosing the right box for ground shipping versus airmail. Okay, so the message is in the right format. What's next? Well, now we got to package and address it so it actually gets to where it's supposed to go. And just like a real-world package needs a shipping label, every single piece of data gets wrapped up with the to and from address. These are the IP addresses you've probably heard of. They're basically the unique mailing address for every device on the internet. And yeah, that's why we're moving from the old standard to a new one, just to make sure we have enough addresses for, well, everything. Okay, but here's where it gets really clever. What happens when you try to send something huge, like a high-def movie, through the network? You can't just shove a giant box into a tiny mail slot, right? The solution is just genius. The protocol takes that massive file and chops it up into thousands of little manageable boxes called packets. Each one gets a number, they're sent off individually, and then, get this, the device on the other end uses those numbers to put it all back together perfectly. And the real aha moment here is how tough this makes the system. If one little packet gets lost, you only have to resend that tiny piece, not the whole movie all over again. All right, our data is packaged, it's addressed. Now what? Let's talk about the actual delivery. Because it's not just about sending it, it's about sending it the right way. You know, protocols are also amazing traffic cops. They manage timing perfectly. First, there's something called flow control. This just means a really fast sender will slow down so it doesn't totally overwhelm a slower receiver. And then, the sender actually waits for what's basically a delivery receipt, an acknowledgement, to make sure the data got there safe and sound before it sends the next piece. Super efficient. And just like your local post office, protocols have different delivery options. You've got unicast, that's like sending a private letter from you to one specific website. Then there's multicast, which is more like a memo to a whole department. Think of a video call to a specific group of people. And finally, you have broadcast. It's like a public flyer for everyone in the area. You see that a lot on local networks, like when your computer's trying to find a printer. So, where are all these messages going? Well, they travel through two main kinds of digital neighborhoods, and they're structured very differently. Let's take a look. And this chart just lays it out perfectly. On one side, you've got peer-to-peer. Here, every device is equal, kind of like a little neighborhood co-op. This is what some file sharing services use. Everyone is both sending and receiving. It's simple, but it doesn't scale up very well. Then, on the other side, you have the client-server model. This is what you're using right now to get this explainer. Your device is the client, and it's asking for data from a big central server. It's super organized, super scalable, but if that one server gets overloaded, everything can grind to a halt. So when you put it all together, the big takeaway here is just how this incredibly complex set of rules is invisibly powering, well, everything you do online, every single second. So let's go all the way back to our first question. How does your phone in one country talk to a server in another? It's all because of these protocols. From turning data into signals and waves, to packaging it up, addressing it, managing the flow, and even defining the networks it travels on, they are the silent, unbelievably efficient engine behind every single email, every video stream, every website. Everything. And that really leaves you with a final thought, doesn't it? What would even one day on an internet without these protocols look like? Without this shared rulebook, our huge, interconnected world wouldn't be a global village. It would just be digital noise.